What's up, Stat 100 team? I'm Jill,
And I'm Celeste.
and today we're going to help you out with some box models. Alright, so you've worked with chance before. We've been looking at all these crazy probability things, but what if we want to find a way to simplify what we're doing in more of a visual sense? What if you're in Vegas this, whatever's coming up, Thanksgiving, and you need to know all your ways to simplify your chances at a roulette, or dice games, or
Let's see
coins?
that roulette. Let's see that
Let's
roulette.
see that roulette.
What
Sorry.
do you got there?
Look at this roulette. So what if you want to simplify every possibility? You can do that with simple tickets from this outlandish box.
Any box would do.
Any box will do,
But that's special.
but that's a good box.
It's a good box.
So first of all, if you're looking at the factors of your box model, it's going to consist of three things. Each ticket of yours is going to have a number on it, right here, one of those things. You've got to have a number of draws, a specific number of draws, and it has to be determined if it is with or without replacement.
Hi again. So here on the board we have 4 examples of how we could translate these into box models. So for example, a coin. We want to flip a coin 10 times and count the number of heads. So every time we flip a coin, we either get heads or tails. Jill?
Tails.
Tails. That is not what we want to count, we want to get a head. So another way to draw this is, okay, so Jill got tails. There wasn't a head. So at that point we got 0 heads. Can you please flip again?
Head.
Head. We got 1 head. Does this box model look okay to anyone?
Wait, did you say a box model is supposed to have numbers?
Yes, correct. A box model is only supposed to have numbers. So somehow we have to get rid of the heads. So the final and simple way to draw this is draw this with 1 and 0. The 1 corresponds to the correct number that we're counting. So we want to count the number of heads. But every time we get a tail, that'd be a 0. So,
I have a question.
yes.
We're talking about a fair coin that comes up heads 50% of the time and tails 50% of the time?
Yes, this is a fair coin that you can find in your pocket, a quarter, a penny, whatever you want.
So when Jill got the head and then the tail, that was just by accident. It would have been drawn this way no matter what she got, is right? Is that correct?
Correct.
Because it symbolizes, I get it. Okay.
It's a fair coin. So now let's incorporate our question. So we wanted to flip a coin 10 times. Do you think that we want to, or we have time to draw 10 ones and 10 zeros? No. The best way to go about this is to draw the box model for one single play for one flip. So every time you flip a coin, it's either 50% chance, a head, or a tail.
And this translates directly into a box, if you want to think about it. A box with our 2 tickets in it. So, yeah.
Yes.
So how then can you, if you only have 2 tickets, can't you only flip it 2 times? Don't you run out of tickets?
Well, that's an excellent question. So every time you flip a coin, you got heads, right? And you flip it again, let's say you got tails. When you flipped it the second time, did you get rid of the heads? No. So in this case, you are drawing with replacement. The first time Jill drew a number, we got a 1, 50-50 chance. So then the next draw, I'm putting it back with replacement. Jill shakes up the box, drawing again, 0, tails. Does anyone have any more questions before we move on? Yes?
So if you wanted to do it 10 times, you'd have to draw 10 times from, like to simulate flipping a coin 10 times, you'd have to draw from the box 10 times.
Correct.
And write down everything you got, like whether you got a 1 or a 0 each time.
Correct.
Okay.
And the reason why we do a single box is because sometimes it's not a simple number like 5 times or 10 times. What if someone wanted to count the number for 500 times? We don't have time to sit there and draw every single one.
Oh, I see what you're saying. Like, it would really be the same thing if you were drawing 500 times. You really could make a box that had 250 ones and 250 zeros, which is, why bother? So,
If it's 50-50 chance,
Just
why
do-
bother?
yeah, I
So-
get it, I get it. And it would still be with replacement,
Correct.
even if you had 250. Okay.
Good?
Yeah.
For our second example, we want to roll a die and count the number of twos. So what I drew out here was each side of the die, just like how we did up here for the heads and tails. So let's play a game. Jill?
Each time I roll a 2, I get $1. So we shake up the box, because that's what it all is. What up? I got a 2. That's $1.
So that's good.
So we have 1, 2. But it's with replacement, so I have to put it back to keep my chances equal. Oh no, I got a 5. It's dead to me, but it has to go back because it's still with replacement.
Correct. And now, how Jill was saying, the 2 was good and the 5 was bad. We want to translate this into the 0, 1 box. So, if Jill was to draw a 1, would that be a 0 or a 1?
0.
0, correct.
Because it's 0 twos.
Yes.
You go, Brenda.
0
Okay.
twos. So for the next one, this is a little crooked. If you were to get a 2, what number would we put in here?
2.
2. Does this look right to you?
Yeah.
Actually, a lot of students are inclined to writing the number 2 because we are counting the number of 2's, but this is a 0, 1 model, like how we did up here. So since 1 is a 0 in the ticket, that's bad. 2 is what we want, so that's good. So we would change that into the number 1.
Oh, because it's 1, 2.
Yes.
You're getting
you're-
1, 2. I see, we're counting the twos. I got it.
Correct. So is 3 a 2?
No, it's 0 2.
So there's 0 twos. And the same goes for 4, 5, and 6. So 3 more tickets.
None of them are what we want. None of them give me $1, so they're all zeros.
Only 1. So every time you do this, do you want to draw this long drawn out box with 5 zeros, 5 bad ones, and 1 good ticket?
No, I'm lazy. I don't want to do that.
So the best way to go about this is again to draw your simplified 1, 0 model with 1, 2, 3, 4, 5, 5 bad sides, and we can put that number up here.
And only one correct answer.
1 correct, 1 up here, because we are counting the number of twos. Okay, so now we are playing another game with our die. Instead of just counting the number of twos, now we're counting the number of spots on a die. So in this game, whenever you roll a die, whatever number it lands on, Jill's gonna win money.
So we go into our little box, and I pick out a number. 3. So now I'm interested because I just won $3.
So let's just keep track of that. 3 over here.
So it's with replacement, so it goes back. Shake it up, because it's like a die. Let me pull it out again. 2. I really don't have good luck, but that's added to my score. So we rolled twice, and I've won a grand total of $5.
Equals $5. Now going back to this, does anyone in the crowd think that this was the best way to draw the box model, or is there any way we could improve on it based on the 3 rules that we had?
Numbers?
Yes,
Yeah, those look like, I think these should be numbers, not spots.
exactly. So these are the number, or this is spots. So what we want to do is actually draw the numbers. Okay, so in this we have numbers 1 through 6. Do you think it's acceptable to draw this into the 0, 1 model again?
No.
No, that's correct. You don't want to draw this out because this time we're interested in the actual number. And because whenever you want to land on a 6 and win $6 instead of just landing on a 1 or a 0 in this case.
So midterms are coming up, right? And you have that just 10 question true or false test that you did not study for at all. Oops. What do you do?
So, what we have here is a box model. So, for every right answer, you get a point, but for every wrong answer, you get 0 points.
And then what if you have that jerk of a teacher who's going to take away when you get it wrong? So you have the first one where you get a point right, and then in the second box, yeah, you got positive one. In the second box, when you get it wrong, that's when they're taking away a point.
Perfect.
So if it was, a question?
Yes.
Yes, Brenda.
So if it was 10 questions, that means you would draw into, it's like closing your eyes, drawing into that box, and whatever you get, like, let's say you got a 1, you write down 1, and then you put the ticket back with replacement, and do it again, draw the next 10.
Yes, you have no idea on any of these questions, so you're just taking a shot in the dark and guessing with each one. Every time is like you're drawing out a new answer.
And what would your score for the 10 questions be, like adding up those 10 numbers you got? Like if you got 5 zeros and 5 ones, your score would be 5.
Your score would be a 50% because it's a 50-50 chance of getting it right or wrong. So this is almost similar to the coin example that we did before. Heads or tails, right or wrong, true or false, you got a point or not, depending on if you got it right.
And then if you have the mean teacher, you're adding up the ones you got right, contrast against the ones you got wrong, since it's taken away.
Yes.
But you wouldn't always get 50%, because you could theoretically get 6 right, or 7 right,
Yes, that
but
is
you make the box 50-50, right?
correct.
Yes.
And some students may think that this isn't correct because we have ones in here and there's no zeros, but that's okay, as long as you have numbers. And in order to distinguish that, you could have the plus and minus sign here.
If that's what helps you figure it out.
Because there's no way to get a 0 on a single question, because that teacher's mean. If it's wrong, it gives you a negative.
So you're headed to Vegas for your Raging 21st. And now we're going to teach you how to count cards. We're totally kidding. We're going to teach you how to study up with your roulette wheel so you can level the playing field a little bit. So this is your roulette wheel.
In the wheel, there is 2 greens, 18 reds, 18 blacks, and the numbers range from 0, double 0, and then the numbers 1 through 36. So a total of 38. Let's say Jill wants to bet. What color would you like to bet on?
Red.
Red, her favorite color. So we know there's 18 reds. How much would you like to bet?
I'm going big, like 100.
$100. So if she gets a red, she's going to win $100. However, if she either gets the green or the black, she loses $100. So we do a minus $100. Like to spin the wheel?
I would. Naturally, I don't get a red.
What'd you get?
I got 2 black.
So
now I'm at $100 and it's a really bad day.
minus 100.
But wait a minute, it's not 50-50, right? How many?
Oh, correct. Good call. So, like I said before, this was 18 red. So if she were to win the red, or get on the red, there's 18 times she can. And then how many times can she not land on a red out of this chart?
There's 20 ways that little thing, is that what's happening? That little ball's falling in a slot?
The little ball spins around and falls in a slot
So there's 20 slots that aren't.
and makes me
okay.
really sad.
So whenever she wins, she has an 18 out of 38 chance of getting the $100, but she has a bigger chance, 20 out of 38, of not and losing the $100. Does anyone have any more questions about this or any of the examples? Perfect. Well, I hope you
Awesome.
guys enjoyed this and come to office hours, like our Facebook page.
Do that.